Hello everyone and welcome to another C++ sorting video, and in this video we will be implementing insertion sort. So in previous videos we did selection sort and bubble sort, so we can go ahead and create a function for our insertion sort as well. So void insertion sort, and it will take the same parameters as selection sort. So it will take our int a array and int size. So size being the size of our array that we're passing in. And the way that insertion sort works is that it needs to go through the array one index at a time, and then for each index it compares the value of that index cell to the one before it, and then starts swapping all the way back along the array until it finds where it should be in that array. And it will be easier to visualize once we start the coding. So for int I equals 0, I is less than size, and then I plus plus. So we're looping through our array from 0 to size minus 1. And then we will save an int j. So int j is going to be equal to I. So we're keeping track of which index we're on at the time. And then since we're always comparing our a at j with a at j minus 1, we need to go all the way back to 1. We can't go to 0, because if we go to 0 we end up comparing it with -1, so we're out of bounds of that array. So while j is more than 0, j minus minus. So we'll keep going back starting from I all the way back to 1. And then in here we will do our comparison. So we'll say that if a at j is less than a at j minus 1, we need to do a swap because the one before it is higher than it, so it needs to be in front of it. So what we can do is int temp is equal to a at j. A at j is going to be equal to a at j minus 1, and a at j minus 1 is going to be equal to temp. And this is it for our swap. Now we need to check if our index is higher than the one before it, and if that's the case we don't need to keep going with this loop because the rest of the array should be already sorted because of the way that we're setting it up. So in this if we'll say that else, so if the value is equal to a at j or less than it, we can just break out of this while loop. So we'll say break. And that should be it for our insertion sort algorithm. So the only thing we need to do now is to keep track of the comparisons and the swaps, just like we did with these functions. So we'll create an int comps, which is equal to 0, and swaps, which is equal to 0 as well. So what we're doing here is that we're doing a comparison right here. So we'll do comps plus plus, and we're doing a swap right here. So we'll do swaps plus plus. And that should be it for our function. We can now add this over here all the way at the end so that we can say that our insertion sort comparisons and swaps are here so that we know how well the algorithm is doing. So if we go down to our main function now, we can create our insertion arrays just like we did for our bubble and selection sort. So we'll do insertion array size, and then we will duplicate it. So duplicate array insertion, and the duplicate function is right here, and that's the function we're calling. We did implement it in one of the previous videos. I think it was the bubble sort video, or might have been the selection sort video, one of the two. And finally we will do the same thing that we're doing for selection sort here. So we'll do an insertion sort on the insertion array, and we will print out the insertion array. And what we expect from the insertion sort is for it to have less comparisons than the selection sort, but it will have more swaps because it keeps swapping along the array until it reaches where the index should be, or the index at that value should be. the value at that index should be. So it will do more swaps than the selection sort, but it should do less comparisons. So let's go ahead and run it and see how it goes. And there we go. So it does 28 swaps compared to the 9 swaps of the selection sort, but it only does 35 comparisons compared to the 45 of the selection sort. So as you can see here, and if we make these arrays bigger, so if we say we need 20 size 20 instead of size 10, we do a lot more swaps, so 96 swaps, but it's almost half the comparison. So it depends on whether you're going for a much better, much lower comparisons or much lower swaps, so you would pick one of the two. Bubble sort, of course, is pretty much the worst of the bunch. So this is it for this video. I really hope that it helped. If you have any comments, suggestions, or feedback, please leave them below. Otherwise, thank you very much for watching, and I will see you in the next video.